Alright, this is tutorial 2, question 11. Okay, as you can see, this question is the same kind of differentiator of m, right? Okay, this is a differentiator of m. Okay, so the question is asking us to find what is the output voltage. Alright, let's read the question first. A triangular waveform, right? It is said that a triangular waveform with a peak-to-peak voltage of 2 volt. Okay, so macam mana tu? A triangular waveform with a peak-to-peak voltage of 2 volt. Right. Let us draw how and see how is the waveform looks like. Okay. So let's say, alright. So this is V in. Okay. V input. The origin is 0. Okay. Now, it is said that a triangular waveform with a peak-to-peak voltage of 2 volt means peak-to-peak. Okay, we know that for a differentiator type of m, okay, the input is in triangular form, right? So the input is in triangular form, means V in triangular form, and it is said that the peak-to-peak voltage is 2 volt. So how are we going to draw it? Means that, let's say, here is the minimum point and here is the maximum point, right? Let us draw some grid then for the maximum and minimum. Okay, when it is said that a peak-to-peak voltage, it means that this is, let's say, this is an input. Alright, we can draw some more. Okay, so I extend the line a little bit. Right? So, what means by peak-to-peak? Let's say this is a maximum voltage and this is a minimum voltage. This means from here to here is peak-to-peak. From here to here is peak-to-peak. Okay, peak-to-peak, dari puncak ke puncak, right? Okay, it says that V peak-to-peak voltage is 2 volt. So, maksudnya, here is going to be 1 volt. Okay, here is going to be another 1 volt. The difference. Okay, so with the resulting voltage from this lowest peak to the highest peak is becoming 2 volts. 1 plus 1, right? Okay, so we can label here. Okay, the highest peak here is positive 1 volt, and the lowest peak here, right, negative 1 volt. Okay, so now we have sort the peak-to-peak information. Now, another information is, from the question, you can see that it says a period of 1 millisecond is applied to the differentiator. Means a period is noted as T, right? T is equals to 1 millisecond. It's given from the question, T is 1 millisecond. So, macam mana kita nak tahu this T? Di mana T tu? How much? From where to where? Okay, we know that a period is one complete cycle. Okay, period is time happens for 1 complete cycle. So in this case, for a complete cycle is to be considered is from here. Okay, let's say from here down here, this point of time, right? And then this is the positive going ramp input, and it's a positive going ramp input. So up till here is 1 complete cycle. So here is T. From here to here is T. Alright? Okay, now we proceed to the question. A period of 1 millisecond is applied to the differentiator. Alright, what is the output? Question is asking us, what is the output? We know the formula is just the same like question 10 previously. Okay? This is the formula. V out equals to negative VC over T RF C. This is the main formula that we get from the lecture notes. Okay, so how are we going to solve V out for this kind of question? Okay, we know that the formula for V out is just the same like question 10, right? So V out equals to negative VC over T, R feedback times C. Okay, so we solve one by one. When it is when the input is positive going RAM, okay, so the V out will be negative. So VC is the input voltage, right? VC we know is the input voltage, and as you can see here, the input voltage is here, the positive going RAM. This is input, okay? This is the waveform for input. So this is the positive going RAM side, right? Okay, and the peak-to-peak value is said to be, and it is given in the question, the information that the peak-to-peak value of the peak-to-peak voltage is 2 volt, right? So from here to here is 2 volts, right? From the lowest peak to the highest peak is 2 volt, okay? So means this is the input for the positive going RAM, right? 2 volt over the time. How much is the time taken is, okay, from the question it is given that the period T, a period T equals to 1 millisecond, okay? So this is period from this point to this point for a complete cycle, for a one complete cycle of positive going RAM and negative going RAM. Okay, this is a one complete cycle and this is one period. It's a period. Okay, a period is given as 1 millisecond. Okay, so for this case we are going to find only for the input when the input is positive going RAM, means for this side only, from this lowest peak to the highest peak, up to this point only. So up to this point only is only half of T, right? It's only half of T. So means here is half of T is 0.5 millisecond, half of 1 millisecond. Okay, so our feedback resistor is 15 kilo ohm times with our capacitor is 0.047, right? 0.047 microfarad. Okay, so we managed to get the answer as negative 2.82 volt for the first V out. For the second V out value, when it is the input is negative going RAM. So V out is equals to this time, this here, from here to here is a negative going RAM. Okay, the slope is negative. Okay, when the slope is negative means the voltage as well, the peak-to-peak voltage value as well is a negative, right? Okay, so this time you will get a positive 2.82 volts. Okay, so these are the two values of voltage V out that we managed to get for the complete cycle of positive and negative. Alright, okay, so now we are going to draw the output. We have these two information. V out is negative 2.82 and positive 2.82. So this is V out, zero line in the middle, and this is the positive and the negative 2.82. Okay, it is said that when it is positive going RAM, okay, here, let's say here, starting from here, okay, when it is positive going RAM, okay, the voltage will go down to negative 2.82. So from the highest peak here of the output, let's say this is, okay, this point, at this time, at this point of time, okay, start from here, go down to, sorry, here, negative 2.82 is here. Okay, it will stay here up until this peak. Okay, when it reaches this time, half of the period, okay, half of the period, when it reaches half of the period, half T, sorry, half T here, okay, it will switch to positive 2.82, positive 2.82, and it stays here until this point. Until this point it changes, so it will change. Okay. Okay, another behind here, so we complete the drawing like this. Alright, okay, so this is T, this is half T. Okay, alright, that's it.